It's the time for the next presentation. It will be the cluster API, operating Kubernetes with Kubernetes by Alexander Demicev. So feel free.
Hey, thanks for coming. This talk will be about cluster API and operating Kubernetes with Kubernetes. But first, I will introduce myself a bit. I'm a software engineer at a company called SUSE, where I work on Rancher, and Rancher is a Kubernetes cluster management platform, includes a lot of things, so I will not go into details about it because it will take a longer time. And today I will try to explain you the problems of cluster lifecycle management, then explain a bit what cluster API is, some building blocks, extensibility of cluster API, then I will tell you a bit about how we play with it in Rancher and also do a short demo. So our first thing is problems of Kubernetes cluster lifecycle management. There are multiple problems, but I chose 4 because I think they are related to KEPI. So we'll try to explain what each problem looks like. So first will be configuration management, infrastructure management, cluster upgrades, and just the general complexity of existing tools. So the first problem is configuration management. It's very easy to lose track of your cluster configurations if you have multiple clusters, and then if these clusters spread across different infrastructures. So if you're running something in the cloud or something like on premises, it's not easy to keep track of all of it. And you also want to be able to have a declarative way to describe the desired state of your cluster, and something has to match cluster that state. Then also, if you're running on different infrastructures, you also want a consistent way and a single operational model to run your clusters in the same way. Like if you're running something in GCP, you want to run your clusters on VMware in the same way using the same API, so it has to be consistent. And also, there is a chance of manual errors, and you need something to reduce this chance of manual errors. And also, tools that you are using, they should be customizable. So if your infrastructure provider is not supported, maybe you want to be able to implement it. Then the second problem is infrastructure management. So before you run your cluster, there has to be something that provisions your supporting infrastructure. There are multiple tools to do that, but if you are operating your Kubernetes clusters, ideally you want something that does it in a similar way for every infrastructure you are running. Then the third problem is cluster upgrades, and it's a very complex topic. Manual upgrades are time-consuming if you have multiple clusters. There is a big chance of causing downtime if you do a mistake, and everywhere where manual intervention is required, the risk of errors is much higher. So you need something to take care of your cluster upgrades. And Cluster API is a Kubernetes 6 project that provides Kubernetes-style APIs to manage your clusters in the same way that you manage your applications in Kubernetes. So you should be able to manage your clusters in the same way that you manage your containers. And KEPI has this concept of management cluster, where all cluster API controllers and custom resources are hosted. And your management cluster looks over your workload clusters, and it provides ability to create them, update, delete, and some other things. So I want to talk a bit about building blocks of KEPI. I will not mention everything, but the most important ones. So our most important object is cluster object, and it represents a Kubernetes cluster. It doesn't matter which infrastructure it's running on. So if you create it, it's just a Kubernetes cluster, and KEPI treats every cluster in the same way. And what's interesting about this resource is that it contains 2 references. The first reference is a reference to an infrastructure cluster. An infrastructure cluster, by infrastructure cluster I mean any cloud that you are using, and it's responsible for provisioning supporting infrastructure like networks, load balancers, VPCs, and so on. It really depends on where you are running your Kubernetes. Then we have a second reference, is a reference to a control plane provider that is responsible for creating control plane machines, generating a cloud config, and helping you upgrade and keeping etcd quorum safe and so on for your control planes. So once you created cluster, once your infrastructure is provisioned, your control planes are also running, then you are able to start adding worker nodes, right? And before I explain you how to add worker nodes, I want to take a look at a concept in CAPI that's called machines. And machine is yet another CRD, and it represents the underlying compute resource. It can be a VM or a physical server, and it's the compute resource that is running your Kubernetes components like kubelet. And CAPI provides an API to manage them. So you can look at machines in the same way as you look at pods. You don't manage your pods by hand, right? You don't create pods. You don't do kubectl apply pod. You don't scale them manually. You don't upgrade them manually. You use something else. That's why we have Kubernetes. If you want to manage the amount of replicas of your pods, you will be using replica sets. And then if you want to do things like rolling upgrades, you are going to use deployments that operate on top of replica sets. And in CAPI, it's similar. We have a machine, then we have machine set to operate amount of replicas, and I have machine deployment for rolling upgrades and so on. So in order to add a set of worker machines, we have to create a machine deployment. And a machine deployment is similar to cluster in a way that it also includes a couple of references. One of them is a reference to infrastructure template, and infrastructure template is a host specification for your machines, like instance type, storage size, etc. All depends on provider that you are running. And the second reference is a reference to a bootstrap config, and it's a component that provides you your cloud config. And I think the most popular and the default one is kubeadm-based bootstrapping. So if you just run CAPI by default, it will use kubeadm to bootstrap your control planes and kubeadm to bootstrap your worker machines. There is much more that can be included, and I don't have time to, unfortunately, but that's autoscaler. Then there are also machine health checks that help remediate unhealthy nodes. Then there's also IP address management. Then there are also add-ons that help with day 2 operations, also cluster classes that are templates for creating clusters, and so on. But what's really important is this CAPI can be extended with your own providers. So you can swap Azure for AWS, for example, like in this picture. Or you can just create anything, any provider you want. And as I mentioned before, Rancher is a Kubernetes management platform. So there are a lot of things that are overlapping with what CAPI does. So we started to play with CAPI a lot in Rancher. And one of the things we did is we created a provider for bootstrapping clusters using our Kubernetes distro called RK2, stands for Rancher Kubernetes Engine. It's a Kubernetes distro that is focused on security. All batteries are included. It's easy to install. So we implemented a CAPI provider for it, meaning that control planes and worker machines are based on RK2. And this can be achieved in CAPI by following API contracts that's a screenshot from CAPI documentation, just one of them. Basically, API contracts is just a set of rules that your API should follow if you want your component to be able to talk to core CAPI. So I'm going to show you a short demo. So I make it bigger. Should be okay. Yeah. So I created a management cluster already to not lose time. Let me check that everything is running. Yeah, I created a management cluster where I deployed CAPI, all CAPI components, so everything is up and running. And I also created 2 clusters here. So one cluster is running kubeadm and it's on Azure. The second one is RK2 based and it's running on AWS. And I wanted to show you how this manifests look like. So first is the cluster object. As you can see, it includes two references. One is to infrastructure cluster. In this case, it's AWS. And it contains specifications for infrastructure that it will provision. And then the second reference is a reference to control plane provider. In this case, it's RK2 control plane. And if we look at RK2 control plane, we can see that it contains things like configurations for your Kubernetes components and also the version of the cluster you're running, and one reference to infrastructure machine template. So AWS KP provider knows how to provision your machines, right? Then after this is created, we may start adding worker machines, and this is done using machine deployment, where we have, again, two references. One of them is a reference to machine template with host specifications, and the second one is a reference to our configuration for Kubernetes. And then I also have a couple resources called cluster resource set, which is an add-on for day-to operations and applying manifests on created clusters. Then I also created an Azure cluster. It's similar to RK2 one, but the control plane bootstrapping is based on kubeadm. And if I wanted to upgrade my control planes, for example, the only thing I have to do is to change the version from 1.25 to 1.26, save the changes, and it should start rolling out new control plane machines. And one other important topic is images that it's using for machines. So in this case, AWS KP provider will try to look up for an appropriate image using parameters that I specified, plus the version that it takes from a control plane object. And I actually had to build AMIs. I can show them. So on my AWS account, you can see there are two AMIs for RK2 125 and 126, and the idea here is that we should include all dependencies in our image, so we don't have to download anything when machine boots. We can just start running Kubernetes, and this is actually achieved through a tool called Packer that we are using, and also Upstream KB is using it to build images. And for RK2, it's easier, because everything should be included in a tarball that we can then use for installation. So if we want to provision an image for RK2, we need to install things like OpenSSH, then Cloud Init, and after this, just download a compressed tar, and then we can run RK2. And also, I can try to extract kubeconfig for one of the clusters and see if it works. I'm going to use a cluster control tool provided by Kepi to do this. And now I will use this to interact with the cluster that I created. Okay, I think the internet is slow, but it worked 5 minutes before. Yeah. So that was it. I was a bit shorter than expected, so we have room for questions, and if you have anything, you can submit it, and I will try to answer it.
There is one question on Slido. So according to your experience, what is the minimum amount of clusters to take full advantage of KPI? Could it be overkill with a single cluster?
It might not be actually an overkill for a single cluster, because you can make cluster manage itself, so it can provide you just a nice tool to manage a single cluster too. right? It's not running API does not take a lot of resources, and it can help you. Of course, you have just one cluster, maybe you don't really need it, but if you want to use it, there is nothing that stops you, and it will definitely help you.
Any other question, even from the audience? One more minute. Sure.
Thanks, Alex. That was a cool talk. I noticed in one of your slides there about or one of the objects you showed for the RKE control plane, you had like a pre-RKE2 command, and you're running sudo there inside of it. So your image is set up to run sudo with no password challenge?
This one is yes. We're still the provider's still in development. We didn't, really make it GA, still in alpha, so we're still playing with it. There are some challenges in running not CAPI, but the RKE2 itself everywhere in the same way, so still going through it.
And what distribution is that using? Is that using the Ubuntu image you were showing before?
Yes, it's using Ubuntu.
Cool, thank you.
It's actually using the same base AMI as upstream CAPI for kubeadm.
Any other question?
So you mentioned those self-managed clusters. This requires this cluster cuddle move command, right?
Yeah.
And what's your take on the ability to delete itself? It's not supported, at least from my experience in infra providers, but are you going to support it for Rancher?
No.
Oh, okay, short question.
So last chance, anyone else? So I was just check the Slido. There is nothing, so I'd like to thank you. And